We have set up a demonstration to show how strong the Galaxy is and why it needs to be this strong. Wood products expand and contract from summer to winter, so whatever is holding them in place needs to allow for this movement. Here we have mounted a section of 4x8 pre-engineered furring to a machined flat steel table. This furring has been sealed on both sides and bolted to this table. It is flat, it's not going to move. Now we have this 4x8 panel set on top that fits into this furring. The two pieces connect together easy and perfectly. It's a perfect setup for showing how strong the Galaxy is. Next, we're going to pull this off and show how much force each of these Galaxies is going to hold. Still at 7, still real close to 70 pounds, still at 70 pounds in full integrity. Let's see where it goes. Up. One finally went over here at 125, and there you go. Plenty strong. So, unfortunately, job site conditions are not perfect. What happens if the panel is exposed to hot, dry conditions, like in the winter when the heat comes on in the building? Well, this is what happens. The panel works as the moisture is out of balance in the panel. Most installers know that a panel with a 1/2-inch bow is not uncommon. How much force is it going to take to push that panel back into the flat position? Well, with this plywood, we're going to warp it now, and then when it gets to about a 1/2 inch of warpage, we're going to show that the Galaxy has enough strength to push down the panel and hold it in place. So we're back in the lab. As what we did is we took the panel from a climate controlled condition here in the shop. We left it outside for an hour, and that dried out the panel. And as you can see here, we've got a bow that's just over an inch, and we're going to put it back on this flat surface, and we're going to show how much force it takes to shove it back flat, and we're going to show that the Galaxy has enough force to make it stay flat given the bowed conditions. So now that we've got the panel laid out and anchored in at some ends, you can see we have successfully messed up this panel. It's got over an inch bow in it, and this happens pretty frequently. You install a job late summer, it's humid, then the job gets finished, the contractor turns on the heat, and the panels start to dry out. What will happen is those panels will shrink up, causing even more bowage, but the Galaxy has both the flexibility and the strength to maintain the integrity of the panel and thus the job as a whole. So what we're going to do is shove this back in and show that the Galaxy has enough strength to hold it. We generally show about 30 to 40 pounds of extra strength for the Galaxy to manage these holes. I'll come in, this side has been pushed in, and you start working your way in. You can see it even holds it, even with the bow in the center. We'll come in, put the last one in. And as you can see, we have the reveal integrity, and the attachment and mounting surface is still intact with enough strength. Now, while this test is extreme, it's not uncommon. This happens a lot on job sites. It's not really anything to do with the installer, but mostly with the conditions of the job site. More information can be found on this on our website, more tests, but this demonstrates well what happens when these conditions make panels bow and how the Galaxy and its strength and flexibility allows it to overcome these conditions. So now that the bowed panel is back in place, we're going to test the strength of it popping out. Start to pull these off. Alright, one pump. You'll see the rest go. On the last test, we showed that the Galaxy maintains its strength in the vertical position, right? And now I'd like to demonstrate the push-pull. So between summer and winter months, a panel will contract or expand just a little bit, And is what we've done is we've cut an 1/8" strip here and put 1/4" shims, and is what that's simulating is a 1/16" contraction on, or expansion on this side, and a 1/16" expansion on this side, which would be a pretty extreme example of expansion between summer and winter months. Now, with this, that's going to push the screws into the Galaxy. The Galaxy has that spacing that allows the strength to still maintain its integrity through those summer months and through that expansion and contraction multiple times over the years. So that's what we're going to do. We have the same strength setup. We're just going to pull this and see when these Galaxies go to failure. 50 pounds. 70. Starting to get a little bit of creep on some of these. No failure yet. Right at 130, 140 pounds before failure.